All right, so we've learned about the fact that proofs prove theorems, and we've got statements that can be true or false, and then they could lead to other statements that are true or false, and then it's those chains of statements, all of them true, that lead to a theorem, and that chain is called a proof. Now, that's a direct proof. You can also have indirect proofs where you assume something is true that is going to turn out to not be true if the proof is correct, and you assume something is false and show that leads to a contradiction. All right, now I want to delve a little deeper into statements. I want to talk about three powerful words that can be placed in statements that have significant meaning. So those words are not, and also or. Okay, so you can make a statement such as, you can say, let's see, something like, the sky is blue. All right, and what about, and then that would be true. Okay, now what about if we said the sky is not blue? How would that affect it? Well, you're saying the exact opposite. Okay, now there's an interesting pattern here that I want you to be aware of. If the left statement is true, the right one is false. At the same time, if the left statement is false, the right one is true. So when you compare, and this is when you have a statement that you've put a not in it, that's called a negation. Okay, a negation of the original statement. Okay, now, so you can always take that to the bank. If one of them, if a statement is true or false, the negation will be the opposite. Okay, it'll always be different. That's what's interesting about negations. All right, now let me now discuss the and. Okay, so what if we did something like this? What if we said, oh, I don't know, how about, I am tired, and then what if we had, I am hungry, and then what if we had a third one, I am tired and hungry. Okay, I hope I'm not making you hungry just talking about it. But so you've got the first one that says I'm tired. The second one is independent. It says I'm hungry. Now the last one says I'm tired and hungry. The important thing to know about the and is that both parts have to be true. Okay? So suppose that I was tired, so that's true. But suppose that I wasn't hungry, so that's false. Okay, I'm still tired, but I'm not hungry. Now the third statement, I am tired and hungry, it's not true that I'm both of those. Okay? So that one is false. Do you see what I'm getting at? So what's interesting about the word and is the bar is raised. It has a lot higher standard in logic. It forces everything to be true. Otherwise, it's false. Okay? So that's what I want to say about that. It doesn't matter if you have 99 things that are true and then you have one little part of it that's false. You can have like this and that and that and that and that. Everything could be true except for one part. It ruins everything. Okay? So that's how ands work. And then now let me talk about or. And we'll go with the tired and hungry again. So let's do I am tired. I am hungry. And this time I'm going to do I am tired or hungry. Okay? So if I'm, let's say it's true that I'm tired, and let's say, you know what, actually, let me type all the combinations. That would be instructive. All right. So I want to do that for for the not NOT example, the negation, and I want to do that for all the ands, and I want to do that for all the or, all the possibilities with the or. Okay. So let me make some room here. But I'll just go ahead and introduce the or before I do that. So suppose I was tired but not hungry. Okay, so one of them is true, one of them is false. Let's go to the third one. I am tired or hungry. All right, that can be true. That is true if only one of the first two sentences is true. So the point here is that or has a much lower standard for truth than and does. Okay, you see that? So and is very strict, or is not strict. All right, so now let's beat this to death. Let's see all the examples. So going back to the first one, the sky is blue. If that was true, and then the sky is not blue would be false. If the sky was blue was false, then the sky is not blue would be true. Okay, so that just exemplifies what I said about that the negation always has a different truth value. Okay, now let's do the purple example, the and example. So if I was tired, so I'll put a true there, and let's say I'm tired and hungry. Well, in that case, I'm both, so I'll put a true on the last one. Let's say I was tired but not hungry. Okay, in that case, the third sentence, I'm tired and hungry, would be false. Okay, what about I am not tired, so that's false, and I'm not hungry, so that is false. Well, then I'm tired and hungry, the both is obviously false as well. And then the last example, what if I was not tired but I was hungry? So the tired is false, the I'm hungry is true. That would also be, that would, I meant to say, let me redo that, I made a mistake. So true and true gives true, but everything else gives false. True, false, false. False, true, false. False, false is false. So there's every possibility for the first two statements for their truth values. And you see everything gives false, every possibility except the first one where they're both true. Okay? Now we said the or had lower standards. Let's look at all the combinations there. So if I'm tired and hungry, so they're both true, then more than enough requirements for being tired or hungry. And then true, I'm tired but not hungry, so true and false. That one is still true. False and true, so this time I'm not tired but I am hungry. That also gets a true. And then I'm neither tired nor hungry. That is the only false. So you see there that the only way that the or case could not be true is if they're both parts are not true. All right. So that's the way not and or work in statements regarding their truth values. Okay. Now, I also want to talk about what are called conditionals. This is where you include the word if in a statement. Okay. So, for example, if it is hot, I will wear shorts. Okay, so if it's hot, I will wear shorts. So the part that the if it's hot, that's the condition that's the part that's after the if, that's the condition. Okay, if the condition is met, then you have the let's call it the consequence. So if the condition is met, then the consequence is true. Okay, so let's look at some different possibilities there. Okay, and we'll just look at a few. So if it's hot, so if the condition is true, then will they wear shorts? Yes, that is true. Okay. Um, and then if the condition is false, okay, so it's not hot, then we can assume that they won't wear shorts. So that will be false. Now you could argue that maybe maybe they'll wear shorts when they're cold, okay? And so maybe you think that it's ambiguous if it's cold whether they'll wear shorts or not. So that's another way to interpret it. What we can be sure of though is that if it is hot, so let me put a question mark around this second one. So really it depends. Um, it really that one might be a little uncertain depending on what they mean by the condition, whether that's the only time they wear shorts or that's just one situation where they wear shorts. Okay, but the important thing is that if it is hot, they will wear shorts. Okay. um, Now, what if you wanted to tighten this up so that there wasn't this question mark on the second case? All right. Then what you want to do is you want them to only wear shorts when it's hot. So to specify that, we will have to do it. We have to also say that this is true. If I wear shorts, it is hot. Okay, so this is another example of here I have a condition and here I have a consequence. Okay, but look, notice that this is the reverse of the first one. Okay, and once again we have this same ambiguity. So if you wear shorts, so yes, we wore shorts, then yes, it's hot. Okay, however, what if we don't wear shorts? Does that mean it's hot or not? Does that mean it's not hot? Well, again, maybe, maybe not. Okay, all we know for sure is that if you wear shorts, it's hot. On the first case, all we know is that if it's hot, for sure we wear shorts. Okay, now let's put both of these together. Okay, let's say let's say the following. This, you can think of this as using an and. If it is hot, I will wear shorts. And I'll make it capital so that it stands out. And if I wear shorts, it is hot. Okay? So now let's look at all of the conditions. Okay? What if it's not hot? Or what if we say it this way? Is if it's hot, then we will wear shorts. If it's not hot, we will not wear shorts. There's no doubt, okay? If it's not hot, we are not wearing shorts. If it's hot, we are wearing shorts. So this time there's no question mark. You see how we got both of them covered? Okay. Likewise, if we wear shorts, then it's hot. Okay. If we do not wear shorts, then for sure it's not hot. Okay. So this one there's no doubt because we've specified it in both directions. All right. The first example where you have a single statement with an if, this is called a conditional. Okay, because it has that piece that's called a condition. Okay, the second one where we specify it in both directions, that's called a biconditional. Why? Well, because we have two parts, they both have a condition. Okay, and they work in both directions. Now, sometimes you have a conditional situation and sometimes you have a biconditional situation. Let me give you an example. Okay, for example, if someone is a Texan, they are an American. Okay, is that's a conditional for sure, but is it a biconditional? Okay, if it was a biconditional, then this would have to be true. If someone is an American, they are a Texan. Is that true? Okay, no, that is not true. You see that? So that's why we say that this one is not a biconditional. Okay, because it doesn't work in both directions. All right, let's try a different one. If someone is a male, they are not a woman. Okay, that's a conditional? Is it a biconditional? All right. Well, let's see. Does it work in the other direction? If someone is not a woman, they are a male. Yes, that is true. Okay, so this one is an example of a conditional. There's only two choices: male or woman, or male or female, male, man or woman, boy or girl. Okay, so that one works in both directions, so that's a biconditional. All right. Now, when you had algebra equations in Algebra 1, you were dealing with biconditionals. Like, for example, if I said x plus 1 is equal to 4, okay, then that if x plus 1 is equal to 4, then it's also if you say x plus 1 is equal to 4, it's also true that 4 is equal to x plus 1. So it works in both directions. Okay? It's not that one implies the other, but the other one doesn't imply the other one, the first one. Okay? Okay, so let me now finish by discussing a use for biconditionality and also the difference between inductive and deductive reasoning. Okay? So biconditionals are useful to make sure that definitions are of high quality. Okay, let me show you what I'm, because we want to have good quality definitions. Let me show you what I mean by that. A hammer is a, let's say if I asked you, what is a hammer? Okay, and you might say a hammer is a tool. All right, that would not be a good definition. Let me show you why. A tool is a hammer. Okay, no, that's see how it doesn't work in both directions? All right, so that's not a good definition. What about this one? A hammer is a tool that pounds nails in. Okay? Now let's see if that one works in the other direction. A tool that pounds nails in is a hammer. Okay, is that one true? Yes, that one works. Okay, so if it works in both directions, then it has a chance of being a good quality definition. All right. Okay, now inductive and deductive reasoning. Suppose you did this. Suppose you deductive reasoning. Okay, so you start. Let's say it this way. Deductive reasoning starts with true statements and uses logic to infer new true statements. Okay, so you make a chain of true statements and You use logic, and every statement for sure is true. Okay. On the other hand, inductive reasoning starts also with true statements and uses patterns to make educated guesses about other true statements. Okay, I capitalized the word guesses because inductive reasoning is not guaranteed. Okay, it can be powerful and easy, but it's not guaranteed. Whereas deductive reasoning is hard, it's not as easy as inductive reasoning, but at least it's guaranteed. All right, so let's do an example of both. Okay, let's do this. All Texans like steaks. Okay, Joe is a Texan. All right, so there's two statements that are true. All Texans like steaks, and Joe is a Texan. Now, using logic, using common sense, we can see that, okay, if Joe is a Texan and Joe likes steaks, so that means we can infer that Joe likes steak. You see how I made a third true statement from that? And because the first two were true, and because we used safe logic to get the third one, we know that the last one is also true. All right? Now, inductive reasoning, let me show you how that one is a lot easier. Okay, watch this. I looked out my window and saw a man. Okay. Yesterday, I looked out my window and saw a different man. Okay, and let's say I kept this going, so every day I would see the same man or a different man. Okay, so therefore, only men live in my neighborhood. Okay, so that's obviously wrong. Okay, there was a pattern. I only saw men for the few days that I did this. So then I extrapolated that only men live on my neighborhood, and I'm only ever going to see men out my window. All right. So the inductive reasoning goes from the specific to the general, which can be powerful when it's correct, but it's not guaranteed to be correct. All right.